Hello and welcome to this video on differentiation. This is the second video in the three. This is about implicit differentiation. So it should cover everything you need for Edexcel International A-Level Pure 4. Two questions on the screen. So you should be familiar with being able to how to differentiate these. If not, you can go back. This is from Pure 3. This is using the product rule and the chain rule and the quotient rule. The solutions linked below if you want to check your answers. Okay, so implicit differentiation. When a function isn't given in the form y equals f of x, so it could be something that's combined. It could be something like x squared plus y squared equals 5, for example. You can still differentiate by using a form of the chain rule. So, in general, what we mean by that is suppose that we have a function in y, and I want to differentiate this with respect to x. So if I want to differentiate it with respect to x, like so, then in general we will get f prime y multiplied by dy dx. And the reason is this is essentially just df dy. Okay, so then our y's cancel out like that. Okay, so a couple of basic examples. If I want to apply d by dx to y cubed, according to this rule, I would differentiate this with respect to y. So I would get 3y squared multiplied by dy dx. Okay, let's try one more. If I wanted to differentiate sine y like this with respect to x, now I just differentiate it with respect to x, so I get cos y multiplied by dy dx. Okay, so basic introduction. Let's have a look at example 1. So find dy dx in terms of x and y, where 4x cubed plus 2x plus 3y squared plus 7y equals 14. Now, where this is especially useful is this is going to be particularly nasty to try and express in terms of y equals. So being able to differentiate the entire thing is really useful. So the way I like to lay this out is I like to write d by dx, and in one big square bracket, I like to put everything in here, like so. Now remember, dy dx is an operator. It's not a function, so it's applied to each term individually. So the way you go through this, so I do d by dx of 4x cubed, so that's just 12x squared, plus d by dx of 2x is 2, plus, now d by dx of 3y squared, so I differentiate this with respect to y, so I'll get 6y, and I multiply by dy dx, plus 7, that's the derivative of y, dy dx. And I differentiate the right hand side, I'll be left with 0. Okay, so now what I like to do is I like to collect everything, all my dy dx's up together. So I'll have 12x squared plus 2 plus, and now I'll get 6y plus 7 dy dx equals 0. Okay, so tidying this up, I can bring my 12x squared plus 2 to the one side, so I'll get 6y plus 7 dy dx equals minus 12x squared plus 2, like so, and therefore dy dx equals minus 12x squared plus 2 all over 6y plus 7. Okay, let's move on to example 2. Given that 7xy squared plus 2xy over y cubed equals 9, find the value of dy dx at the point 1, 1. Now, just a little something here. When we're trying to find a point, we don't actually have to rearrange for dy dx. You can do if you'd like to, but you can just put everything in if you prefer. Now, this one, we have a product in here, so we are going to have to be careful. I'm going to rewrite this, doing the same way as I did last time, but I'm going to bring the exponent up like this, just to make our life a little bit easier. Okay, so let's begin. So the product rule, remember, so I have to differentiate this and multiply by this. So to begin with, I'll get the derivative of 7x, which is 7, times y squared, plus 7x times the derivative of y squared with respect to y, which is 2y, multiplied by dy dx. Just need to be a little bit careful with this section. Now, plus the derivative of 2x, which is just 2, multiplied by y to the minus 3. And then it's going to be plus 2x multiplied by the derivative of y to the minus 3, which will give me minus 3y minus 4 times dy dx equals 0. Now it's at this point, you can either rearrange for dy dx, but since we don't have to, we can just substitute the points we want to put in. So I'm going to do this. So at 1, 1, I will get 7 times 1, add 7 times 1 times 2 dy dx, add 2 times 1, because 1 to the minus 3 is still 1, add 2 times 1 times minus 3, because y to the minus 4 is just, 1 to the minus 4 is just 1, times dy dx, and that equals 0. So now tidying this up, I get 7 plus 14 dy dx, add 2, minus 6 dy dx must equal 0. And if I continue to tidy this up, I have 7 and 2 here. So if I bring those to the other side, I get minus 9 equals 8 dy dx, and therefore dy dx equals minus 9 over 8. Okay, so where possible, try and make your life a little bit easier. Okay, so let's take a look at example 3. So I have another function. So the first thing I'm going to do is just rewrite this in a bracket where I can apply my operator to it. Now this one has some trig and it's going to make use of the product rule. So we just need to be a little bit careful. So if I apply d by dx, I'll get 2x times sine y plus, now I'm going to leave x squared and I'm going to differentiate sine y with respect to y. So I'll get cos y times dy dx. Plus, now y squared, I'll get 2y dy dx times the sine x. Okay? Plus, and I'll get y squared times cos x equals 0. Now, like in the previous examples, I'm going to group together all of my dy dx's. So I've got x squared cos y dy dx. I've got 2y and sine x. So don't forget it if you write it in this order. So I get 2y sine x, close those brackets, dy dx, plus I have my 2x sine y plus y squared cos x equals 0. So I can rearrange this in one step if I'm careful. So I'll get dy dx I'll take this to the right hand side, so I'll get minus 2x sine y minus y squared cos x all over x squared cos y plus 2y sine x. Okay, and you should notice actually it's a little bit symmetrical because the question was kind of symmetrical, so we had x squared sine y, y squared sine x. I've got a 2x sine y, 2y sine x, a y squared cos x, and then x squared cos y. Okay, let's move on. Okay, so let's have a look at this exam style question. So a curve is defined by x cubed minus 4xy equals 8. Find the equation of the tangent at the point 2, 0. Give your answer in the form ax plus by plus c equals 0. So I'm going to start this the same way. I'm going to apply d by dx to the entire equation. So then I'll get d by dx of x cubed, which is just 3x squared. And here I have to use the product rule. Now I've got a minus in the front, so I'm just going to do the entire thing in a bracket. So I'll get 4 times y plus 4x times the derivative of y, which is 1 with respect to y. So it's just times dy dx. Okay, and that equals 0. Now, because I don't actually need to find an expression for dy dx, I can just substitute my points in here to make my life a little bit easier. So if I do that, I'll get 3 times 2 squared minus 4 times 0 plus 4 times 2 dy dx, and that must equal 0. So tidying this up, I get 12 minus 0, so then I get 12 minus 8 dy dx equals 0, and therefore 8 dy dx equals 12, and putting those together I get dy dx is 12 over 8, which is just 3 over 2. Okay, now I need to just find the tangent. So I just need to put this into the equation of a line now. So I get y minus 0, that's my y coordinate, equals 3 over 2 x minus 2. So I'm just going to multiply it by 2. So I'll get 2y equals 3 bracket x minus 2. So 2y is 3x minus 6. Nearly made a silly mistake there. So 3x minus 6. And therefore, tidying that up, I can get 3x minus 2y minus 6 equals 0. Okay. Okay, so let's take a look at one final stretch question. So I have a curve x squared plus xy plus y squared equals 12. Find the value of the gradient at the point 2, 2. And part B, find the x coordinates of the stationary points of the curve. Now normally if I just wanted to find a value, I could just put my points in when I differentiate this and not find an explicit expression for dy dx. But since I know I'm going to have to actually use dy dx again, I will find the full expression for it this time. So, start by laying our working out correctly. So that means when I apply this, I should get d by dx of x squared, which is 2x. Here I'll have to use the product rule. So I'll just get plus d by dx of x, which is 1, times y, plus x, times the derivative of y, which is dy dx, plus the derivative of this with respect to y, so 2y dy dx equals 0. Okay, now I'm going to tidy all this up. So I'll get x plus 2y brackets dy dx plus 2x plus y equals 0. So that means my dy dx is minus 2x add y over x plus 2y. Now at the point 2, 2, this becomes minus 2 times 2 plus 2 over 2 add 2 times 2, which is minus 6 over 6, which is minus 1. Okay, so that's part A. A. Now, for part B, I'll change the colour of the pen. So, at the stationary points, well, that's when dy dx equals 0, which means that's when minus bracket 2x plus y over x plus 2y is 0. Now, that will happen when the numerator is 0. So when minus 2x plus y is 0, or, in other words, just when 2x plus y is 0. So therefore that occurs when y equals minus 2x. Now, that isn't an actual coordinate, so what I'm going to have to do with this is I'm going to have to put this back into the original function and then solve for x. So, I'll get x squared plus x times minus 2x plus minus 2x all squared equals 12. Now, this is quite a nice one. So I'll get x squared minus 2x squared plus 4x squared is equal to 12. And therefore I've got 1, 4, so I get 5, take away 2, so I'll get 3x squared is 12, x squared is 4, and therefore x is plus or minus 2. So those are the x coordinates of the two stationary points. And that's the end of the question. Done. Thank you for watching. I hope you found it useful. If you did, like or subscribe, comment. Thank you.